Hello viewers. So இந்த வீடியோல நம்ம பார்க்க போறது initial value and final value theorem ஆன லாப்லாஸ் ட்ரான்ஸ்ஃபார்ம். ஸோ ஃபர்ஸ்ட் நம்ம பார்க்க போறது வந்து என்னன்னு பார்த்தோம்னா initial value theorem. So we know that the Laplace transform of x of t which is equal to x of x. So அப்படி இருக்கும் பட்சத்தில் the initial value theorem states that x of 0 which is equal to limit s tends to infinite into s into x of s. So இதை நான் rearrange பண்றேன் அப்படின்னா I take limit t tends to 0 where x of t which is equal to limit s tends to infinite s into x of s. So here t is equal to 0 அப்படின்றதுனால I take it is initial. Suppose t tends to infinite இருந்தனா with time to with respect to time it should be infinite. So I take it is final. So that is the only difference. So இதுதான் வந்து என்னுடைய initial value theorem. So இப்போ இதை தான் வந்து நான் என்ன பண்ண போறேன்னா ப்ரூஃப் பண்ண போறேன். சரிங்களா? So in order to prove this initial value theorem I go for differentiation property. So which we discussed in our previous videos. Just go through it. So we know that Laplace transform of d into x of t divided by dt which is equal to s into x of s minus x of 0. So we know this. சரிங்களா? ஸோ இதுக்கு நான் லேப்லாஸ் ரெகுலர் இன்டெக்ரல் 0 to infinite. ஹியர் எஃப் ஆஃப் டி இருக்கிற இடத்துல எனக்கு என்ன இருக்குன்னா dx of t இருக்கு. ஸோ ஐ டேக் dx of t divided by dt into e power minus st into dt. So instead of f of t I use x of t here. That is the only difference. There is no need to confuse. Okay. Suppose if I put t tends to infinite, this entire term is equal to 0 because we know that e power minus infinite which is equal to 0. Okay, so here e power minus st act as a damping factor. Okay, so this term which is equal to 0 whenever my time period approaches infinite. Okay, so that here the integral limit is with respect to t only. Okay, no issues. So therefore s into x of s minus x of 0 which is equal to 0. Okay, so here it should be infinite, then only the term which is equal to 0. So therefore here the limit applied which is equal to s tends to infinite. Okay, so here in this term there is no s domain is there, so I rearrange like this s into x of s minus x of 0 which is equal to 0. So now I rearrange x of 0 which is equal to limit s tends to infinite s into x of s. So this is my required proof. Okay, then I move on to final value theorem. So in final value theorem it states that limit t tends to infinite x of t which is equal to limit s tends to 0 s into x of s. So this is the statement of final value theorem. Here t tends to infinite and s tends to 0. It is very easy to remember, and t and s is inversely proportional. Okay, if t is 0, so then s tends to infinite. If t tends to infinite, yes, it should be 0. So like that you should remember. சரிங்களா? So but therefore again I use the differentiation property. Okay, so therefore the Laplace transform of dx of t divided by dt which is equal to s into x of s minus x of 0 which is equal to integral 0 to infinite d into x of t divided by dt into e power minus st into dt. Now I apply the limit s tends to 0 on both sides. So ரெண்டு சைடுமே நான் வந்து லிமிட் அப்ளை பண்ணா எனக்கு என்ன கிடைக்கும்னா so limit s tends to 0 s into x of s minus x of 0 and limit s tends to 0 integral 0 to infinite dx of t divided by dt into e power minus st into dt. So I rearrange like this. So s into x of s minus x of 0. Here there is no s term is there, so I just separate like this. Okay. So which is equal to limit is integral 0 to infinite dx of t divided by dt, and I put limit s tends to 0 e power minus st into dt. Okay. So here the value of this is equal to 1 because e power 0 which is equal to 1, and this dt will cancel. So remaining இருக்கிறது வந்து integral 0 to infinite dxt அப்படின்ட்டு இருக்கும். If I integrate this x of t limit 0 to infinite அப்படின்னு வந்துடும். So therefore limit s tends to 0 s into x of s minus x of 0 which is equal to upper limit minus lower limit. So this term will cancel. So therefore x of infinite which is equal to limit s tends to 0 into s into x of s. So this is the required proof for the final value theorem. Thank you.